Before we look at your blue note paper, would you graph this in the Y1 part of your calculator and look at the graph in your calculator? You're not convincing me you're doing that if you're not picking up your calculator. Pick up your calculator and put Y equals 0 to the x power and look at the screen, and it looks like nothing happened. But actually, something did happen. There is a graph. It just happens to be right on top of the axis. So if you look at the table, you will see that it is constantly 0. So there is a graph right there. It's just right on top of the axis. Is that growth or decay or neither one? Because it stays flat. Okay, now look at 1 to the x power. What do you see if you put 1 to the x power? That's the table, that's the graph. Is that exponential? Is that growing or decaying or staying the same? That's a constant equation, it's staying the same. You cannot have an exponential equation that has 0 as the base. You cannot have an exponential equation that has 1 for the base because it's not exponential. It doesn't grow, it doesn't decay. But have a look at this one. Y equals 2 raised to the x power. Put that one in the y equals part of your calculator. Do you see a growth, what appears to be a growth graph? Is it growing? It also appears like it stops. Well, let me get back over here. Doesn't it appear that this goes up like this, but it looks like it comes down here and stops? But it doesn't really. Because if you look at your table, if you scroll through your table, you will see that it's getting bigger and bigger and bigger. If you scroll through the negative numbers, do you see that it's getting smaller and smaller and smaller? But does it actually go to 0? It gets smaller and smaller and smaller, but it doesn't ever actually go to 0. What do you call that when it gets closer and closer and closer and closer to something? No, that too, but on a graph, what do we call that? Line. Asymptote. This graph is going to have an asymptote. And so this is going to increase, and this is going to get closer and closer and closer to 0, but it's never going to actually get to 0, and so this line across here is called an asymptote. Okay, please look at your parent graphs on the blue paper. So, we start off, is it obvious from the graph why this would be called a growth equation? Now, this is not stopping here. This is continuing on, and it goes on and on and on. Now, pick up your pencil. This point right here is a very important point. It is a key point. I need you to color that in with your pencil. I'm going to be talking about a key point, and this is the key point that I am talking about. Do you see that they all have a y-intercept at 1? And they all have, all of these parent functions have horizontal asymptotes right here. The domain is all real numbers on all of these. The range is y is greater than 0. In interval notation, that's how you would write y greater than 0 in interval notation. Now, the trickiest part of this is figuring out what the b is in each problem. To find out the B, put your pencil on your key point, go 1 to the right. This distance from the asymptote is how you figure out what the B is equal to. From the key point, you go 1 to the right. This distance right here is the B. From your key point, where do you go? 1 to the right, find a pretty point. This distance right here tells you what the B is equal to. So that key point is going to be very important. The first thing we're going to need to do when something has been moved up or down or left or right is find that key point. That key point is 1 unit above the asymptote. In example number 1, here is the asymptote. The parent graph had an asymptote in that same place, so it hasn't been moved up or down. But it has been moved to the left or the right. On the parent graph, the key point is here. On this graph, the key point is at 3. How do you figure out the B? You go 1 to the right and count this distance, not from the key point, but from the asymptote. Now, I don't know if this is on your notes, so you may want to write this down in the bottom margin. We are filling in this equation on all of our problems here. We're going to let the A be equal to 1, and so we're not going to write the A. B to the x minus h plus k, just like we've done before. A number up here with the x moves it left or right. Number added or subtracted down at the end moves it up or down. So this is the equation we're filling in for the function. You can put y equals, we usually use g of x for the transform. B, x minus 3. Move that over a little bit. 2 raised to the x minus 3 this is the function equation. Why is it, this is 3. Why did I say minus 3? X is still a liar. Next problem. This is where the asymptote is. The asymptote crosses the y-axis at 0. This, how do I know that's the key point? I was about to say this is the key point. How do I know that's the key point? It's 1 unit above the asymptote. You find the point that's 1 unit above the asymptote, and that is at -4. How do I find out what the B is equal to? That distance right there is the B distance. 1 unit to the right of the key point. So this is going to be g of x equals base 3 raised to the power of x plus 4. And then it hasn't been moved up or down. Just want to mention, if you wanted to look at that in your calculator, you would be required to put a parenthesis around the x plus 4, or it wouldn't graph correctly. Okay, example number 2. Right there, we always need to start with our asymptote. Our asymptote is at y equals 4. It has been moved up 4. The parent graph has the asymptote here, and that's been moved up 4. Where's the key point? The key point is 1 unit above the asymptote. The key point is on the y-axis. The parent graph is on the y-axis, so it has not been moved left or right. Did you find the B already? That distance right there is the B. Put it all together in an equation. This is base B raised to the x power plus 4. This plus 4 is not part of the exponent. This plus 4 is at the end because it moved up. On the previous problem, this plus 4 was part of the exponent. Make sure it looks like it because it moved left to B. Here is the asymptote, and the parent graph is at 0, and this has been moved down 5. Do you know why that's the key point? It's 1 unit above the asymptote. It is on the y-axis just like the parent graph. That means it hasn't been moved left or right. This distance right here is the B. 1 unit to the right gives you the B. Let's see, the asymptote is at y equals -5, and the equation is base 3 raised to the x power minus 5. Say again? K gives you the asymptote. Is that what you meant? And the asymptote is y equals because it's crossing the y-axis. Okay, this one I believe has more than one transformation. Here is the asymptote. The asymptote is at y equals 1. That means it's been moved up 1 because the parent graph has an asymptote at 0. Here is the key point. That's the key point because it's 1 unit above the asymptote, and that is over here at 3. The x value of that point is 3. This distance right here gives me the B. So the function is g of x equals 2 raised to the x minus 3 plus 1. The x minus 3 is all in an exponent. Make sure the x minus 3 looks like an exponent. If you were going to graph this in your calculator, a parentheses would be required around that. The domain is all real numbers. The range is asymptote and up. Example number 4. Where is the asymptote? The asymptote is at -5. It has been moved down 5 because the parent graph has an asymptote at 0. This is the key point because it's 1 above the axis, And so that key point is at -1. 1 to the right, this distance right here is what I count to figure out what the B is equal to. 1, 2, 3, 4. Put it all together. For the equation, base B, x plus 1 minus 5. X is still a liar, so if that's a minus, this is a plus. Asymptote up is the range. Okay, you complete problem number 5. The last problem is like the problems that were on the salmon colored paper, so you don't forget how to do those. So is this particular problem a growth problem, growth or decay? How much did the jewelry start out? Now, before you find the B, I need to change this into a decimal. It's a percent. What decimal is that equal to? And so the growth rate is add 1 to that because it grew starting at 100% and then it grew. And so what's the time between 2020 and 1980? What's 2020 minus 1980? And so all we have to do is fill in this equation. The initial amount is 700. This is the B, the multiplier raised to the 40 power. And so that's 700 times 1.018 raised to the 40 power. And so it more than doubles in value. Now, because we're not going to be in this classroom tomorrow, I need to go ahead and do a little bit of explaining the next notes. They're very similar, but on the gold notes, if you look at these equations, are they increasing? They are decreasing. And so these are the first 3 examples from the blue notes. Those are increasing. These are first 3 examples from the gold notes. They are decreasing. And so we still have the same key point. But if I try to read this 1 to the right of the key point, am I going to be able to figure out what that is? So the only difference is on a decreasing, instead of counting to the right, I count to the left. Can I count that distance pretty easily? But it's not a 2. It's a 1/2, not a negative. It's a 1/2 because what makes it decrease? It has to be a number less than 1. So here's my key point, but instead of counting to the right, I count on the left. Are you marking this on your gold paper? 1, 2, 3. But instead of being a 3, because it's decreasing, it's a 1/3. That's the only difference here. Here's my key point. Instead of counting on the right-hand side, I count on the left-hand side. 1, 2, 3, 4. But instead of being a 4, when I put it into the equation, it is a 1/4. So on your gold notes, would you please skip over to example number 3. On the parent graph, we have an asymptote at 0, but on this graph, we have an asymptote at 1. The key point is still 1 unit above the asymptote, so the x value of that key point is 3. Now, do you see that this is a decay equation? I can't count 1 to the right. It's too small. So I count 1 to the left. But the b is not 2. The b is 1/2. Because if I put a 2 in there, it wouldn't be decay. And so the equation is going to be 1/2 to the x minus 3 plus 1. The domain is still all real numbers. The range is 1 to positive infinity. Example number 4. Okay, on example number 4, let's see, that asymptote is at y equals 4. That means the whole graph has been moved up 4. My key point is right here. The x value of that key point is -2. Since this over here on the right-hand side is too little to count, I count on the left-hand side. 1, 2, 3, 3. But it's not 3. The b is not 3. It is 1/3. Guess what people forget to do on quizzes and tests? You forget on this kind of problem to put 1/3. And so this is going to be base of 1/3, x plus 2 plus 4. Why is there a plus 2? I thought it was a minus 2. Still lying. Okay, you complete the next example. So, did you complete these correctly?